Hello everyone, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faisi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to explain about absolute zero. What is absolute zero? Theoretical temperature at which a gas would have zero volume and no pressure. I repeat, theoretical temperature at which a gas would have zero volume and no pressure. Zero volume and no pressure. I repeat, theoretical temperature at which a gas would have zero volume and no pressure. Calculated by extrapolations. So 0K is equal to minus 273.15 degrees Celsius is equal to minus 459 Fahrenheit. Kelvin Celsius T plus 273.15. Never attainable, though we have gotten real close. All gas law problem use Kelvin temperature scale. So, what is Charles' law? Volume is directly proportional to temperature. Constant pressure and amount of gas. Graph of volume versus temperature is a straight line. As T increases, temperature increases, volume also increases. So V is equal to constant into temperature. If T measured in Kelvin, V1 divided by T1 is equal to V2 by T2. So plots of volume liter versus T degrees Celsius for several gases. This is T 0 degrees Celsius. This is the V in liter. So high temperature, large volume. Here is the higher volume. So this is lower volume and this is the higher volume. So volume, you see, of different gases are different: N2O, H2, H2O, methane and helium. Low temperature is small volume. If the temperature is high, and low temperature, low volume of helium. Now you see about the methane, about the H2O, about H2, you see. So plots of V versus T as in figure, except that here the Kelvin scale is used for temperature. Now here you see 0, this is the volume increases, the temperature increases. So 0 Kelvin of helium, and here you see this is started from here, started from here, started from here. H2 and N2. So H2 and helium started from here. What is Avogadro's law? Volume directly proportional to number of gas molecule. What does it mean? Volume is equal to constant into n moles. Constant pressure and temperature. More gas molecules means larger volume. V1 N1 is equal to V2 by N2. Count number of gas molecules by moles. 1 mole of any ideal gas occupies 22.414 liter at standard conditions. At standard condition, remember this is molar volume. What is called molar volume? Equal volume of all gases. Gases contains equal number of molecules. It doesn't matter what the gas is. It doesn't matter. I repeat, it doesn't matter what the gas is. Ideal gas law. By combining the proportionality constant from the gas law, we can write a general equations. R is called gas constant. The value of R depends on the units of pressure and volume. Generally use R is equal to 0.08206 when P in atm and V in liter. Use ideal gas law when have gas at one conditions. So most gases obey this law when pressure is low. I repeat, most gases obey this law when pressure is low. When pressure is low. When pressure is low. At or below 1 atm, and temperature is high above 0 degrees Celsius, and temperature, so pressure is low below 1 atm and above 0 degrees Celsius. If a gas changes some conditions, the unchanging condition drop out of the equation. So this is equal to PV is equal to nRT, well known ideal gas law. So P1 multiplied by V1 divided by T1, P2 multiplied by V2 divided by T2. So what is Dalton's law? The total pressure of mixture of gases equals the sum of pressure each gas would exert independently. Partial pressure is the pressure a gas in a mixture would exert if it were alone in the container. So P total is equal to P gas A plus B gas B and so on. Particularly useful for determining the pressure of a dry gas would have after it is collected over water. P air, P wet gas, P dry gas plus water vapor. So pressure of water vapor depends on the temperature. So partial pressure of each gas in a mixture can be calculated using ideal gas law. For gases A and B in a mixture, you know the P A is equal to Na multiplied R multiplied by T divided by V. Another gas PB, pressure of B, moles of B into R into T divided by V. The temperature and volume of everything in a mixture are same. So N total is equal to Na plus Nb. So P total is equal to Pa plus Pb is equal to N total into R into T divided by V. Now the kinetic molecular theory. What is the kinetic molecular theory? The properties of solid, liquid and gases can be explained based on the speed of molecules and attractive forces between molecules. In solid, the molecules have no translational freedom. They are held in a place by a strong attractive force, may only vibrate. In liquid, the molecules have some translation freedom, but not enough to escape their attraction for a neighboring molecules. They can slide past one another, rotate as well as vibrate. In gases, the molecules have complete freedom from each other. They have enough energy to overcome all attractive forces. Kinetic energy depends only on the temperature. So describing a gas, gases are composed of tiny particles. The particles are small compared to the average space between them. Assume the molecules do not have volume. Molecules constantly and rapidly moving in a straight line until they bump into each other or the wall. Average kinetic energy proportional to the temperature results in gas pressure. Assume that gas molecules attraction for each other is negligible. So postulate of kinetic molecular theory of gases. This is important. Gas consists of tiny particles, atom or molecules. These particles are so small compared with the distance between them that the volume size of the individual particles can be assumed to be negligible, zero. Particles are in constant random motion, colliding with the walls of the container. These collisions with the walls cause the pressure exerted by the gas. Particles are assumed not to attract or repel each other. The average kinetic energy of the gas particle is directly proportional to the Kelvin temperature of the gas. So these are the postulate of kinetic molecular theory. This is important for examinations, written examinations. So gas properties explain gases have indefinite shape and volume because the freedom of the molecules allows them to move and fill the container they are in. Gases are compressible and have low density because of large space between the molecules. The meaning of temperature. The temperature is a measure of average kinetic energy of molecules in a sample. Not all molecules have same kinetic energy. Kinetic energy is directly proportional to Kelvin temperature. I repeat, kinetic energy is directly proportional to Kelvin temperature. Average speed of molecules increases as the temperature increases. So what is the relation between pressure and temperature? As the temperature of gas increases, the average speed of molecules increases. The molecules hit the side of the container with more force on average. the molecules hit the side of the container more frequently. The net result is an increase in pressure. So, volume and temperature relationship. In a rigid container, raising the temperature increases the pressure. For a cylinder with a piston, the pressure outside and inside stay the same. To keep the pressure from raising, the piston moves out, increasing the volume of the cylinder. As volume increases, pressure decreases. Repeat, volume increases, pressure decreases. So what is gas stoichiometry? The general algorithm discussed previously to convert masses or solution amount to mole. Use gas law to convert amount of gas to mole or vice versa. So friend, hope this video will be helpful to you. If you like this